My name is Asano. I'm from DevU Corporation in Japan. I would like to talk about OpenVG, and I would like to get in a little bit further into the API level. This is my talk today. Let me introduce my company first. Takumi is a Japanese company, and we provide 3D, 2D, and VG graphics accelerated IP to the embedded market. And we located Tokyo, and we already released over 30 licenses. This slide says that Khronos Standards API is a benefit. Of course, everybody knows about this. Excuse me. You will have lots of middlewares, or like a Flash and font engines, map engines, on top of OpenVG. This is an example of OpenVG application. OpenVG is good for GUI, I think, and also font rendering and also map rendering. These maps are used in the device which has the GPS, and the digital cameras has GPS right now, and they need the map rendering features in camera device. Let me introduce some of the application examples here. One is photo viewer. OpenVG has the good anti-aliasing features, and also have a perspective transformation for images. So you can render image like 3D without jaggies at the edge. As I said, that the OpenVG is good for rendering fonts and maps. In OpenVG, you can utilize the Bezier curve, very smooth curve, without aliasing, and you can also transform by matrix. It is very useful to render fonts and maps. Image filter is one of the characteristic features in OpenVG. Especially blur filter is good effect and expected effect in the market. This is kind of an experimental result. The most left image is original, and we do shrink the image to 64 by 64. The original one is 206 by 256 by 256, and used by linear filter. It gives you a little bit, a little blur effect, but it is not enough. So we use Gaussian blur to have the blur effect. As you see, if you use the Gaussian blur filter in VG, you can have a very good blur effect. However, it's better to have a smaller image to apply the Gaussian blur, because it is very, very expensive calculation is needed. And of course, you know that Khronos provides common API, but implementations are different. So there are a wide variety of implementation in the market. So how to improve your application performance? I think better way is understand your understanding architecture, the device you use, I mean the characteristics and the natures of the device. And of course, you have to understand the bottleneck. Maybe it changes by application. And also, it is better to understand what is happening in API and GPU. This is a famous 8 pipeline stage in OpenVG. It is covered by Dr. Lee. So let me go through very quickly. This is hardware implementation. And even the hardware implementation, there are lots of types. So this is just an example. And also, it has software-based implementation, like Hwanyong has. And also, there is a half and half type. And also, there are OpenVG on top of 3D hardware. And if you have OpenVG on top of 3D hardware, you need a triangle tessellation. And it is very heavy process, usually. And one more thing you need to know about the pipeline is the pipeline is very deep in the hardware. So there are hundreds of commands in the hardware pipeline simultaneously. So if you say stop to the hardware, but there are lots of commands that are stuck in the hardware, so the hardware cannot stop immediately. You need to wait like a microseconds or nanoseconds to flash all the commands. So there is critical requirements in the embedded market. It is important to minimize CPU load. Actually, CPU is not only for graphics. They are doing lots of other operations. And in the market, there is a high-end CPU or devices. The CPU is like 1.5 gigahertz with APU, and it could be dual or quad nowadays. However, there is also low-end market, and low-end market, the CPU is without FPU, running in like a 200 megahertz or less. And another thing, important thing is use memory very efficiently. In the embedded device, memory is usually limited. So you have to use memory very efficiently. And also, it is important to reduce the bus traffic to have the performance. And last one is not the requirement for software. It's a hardware requirement, but the hardware need to be small because hardware size is the power consumption. So we have to maintain the LSI size very small. For now, I would like to talk about programming tips at the API level. In the API, of course, there is a lot of useful functions, but you need to use them very effectively. I would like to introduce kind of a general programming tips. There are lots of implementations, so maybe there are another tips. For our hardware, we have our own tips. So it is kind of a common tips, I think. So, and it is better to know the timing to use the function, and also better to know what happens when you call the function. And you better know your device, what kind of features it has, or what kind of performance they have. It is important to keep object numbers small. If you have lots of objects, there are lots of overhead to checking error or malloc. So it's better to cache object as much as possible. However, delete the unnecessary objects. And avoid unnecessary setting functions like VG set parameters. I think you are a good programmer, so you don't do this, but actually I observe some implementation do this thing, set parameter over and over, and even if it is same attribute. And matrix calculation is very heavy, so it's better to avoid the calculation load. So if you can have pre-calculated matrix, then use that and set with VG load matrix. And avoid unnecessary VG finish. VG finish is very simple, just finish rendering, but the it needs pipeline sync, so you have to wait. All the command is go through the hardware pipeline, and the pipeline gets empty. Also, other read pixel, write pixel, other accessing to the buffer stuff functions is the same thing. You have to certain that everything is written on the color buffer. And if you add or create the path data, do it at once. If you use append path data to add paths and do it again, then the API need the real operation, and real operation is very heavy for CPU. And also the path modification functions, these functions could be CPU load. It depends on API implementation. And also, good programmer do not do this, but sometimes I see that the path object is created and used and destroyed. And this happens in each frame, or even if it is same object. It's kind of stupid, but I see sometimes these things in the implementation of application. And also, you don't do this, but it is better to use floating point setting the function for floating point and integer point setting in with the integer setting functions. So type conversion is also heavy for the CPU, especially for low end. If you have a very high-speed CPU, it doesn't matter. But, it is sometimes unnecessary CPU load. And that's in the image filtering, it's better to use small column with a small image, because image filter function is very, very heavy. even for the GPU. And avoid using VGU functions. VGU function is kind of a utility function for vector graphics, and it's very, very useful. However, it includes a lot of heavy floating point calculation. So you can use, of course, but be careful. You need to know what happens in CPU calculation. And also, the change in context is very heavy for hardware pipeline. You have to sync the pipeline. Sync means you have to wait that all the commands go through the pipeline and be empty. Or you have to set register or load register. This kind of thing is very heavy, so don't switch the context frequently. That's it. Thank you very much.